Hi everybody. We're going to do a really fun lab today. Actually, I'm going to do it and you get to watch me do it and then get the data that I give you. So if you look on the table here, I have a cart on this track. There's a string attached to this cart. The string runs over a pulley, and right now there's no weight on the end of the string, but I'm going to put weight on the end of the string. And so here's the weight, and so what's going to happen is this weight is going to be pulled down by the earth. It's going to pull on the string. It's going to make the cart move. Right now, not only does it move, but you'll notice, you might be able to see it from your point of view. As it's moving, it's speeding up. All right, so what we can do here is to do an experiment. We can change the weight on the end of the string and see how it affects the acceleration. Now, let's start out. I want to point out that when I let this go, not only is the cart accelerating, but the weight on the end of the string is also accelerating. All right, so what I did was I made the total mass of this cart plus the weight on the end of the string 3 kilograms. So just keep that in the back of your mind that the total mass is 3 kilograms. But because I want to keep the mass constant, when I change the weight on the end of the string, it has to come from here, all right? Or if I move weight off the string, it has to go back on here. So the total mass of everything is 3 kilograms. Okay, but first of all, I'm going to start with no weight on the end of the string, all right? So in other words, the force pulling this is 0. I think you can see that the acceleration is 0. So that's your first data point. All right, so you're going to make a data table for net force and acceleration. The net force will be the weight on the end of the string. And that's going to be the only force because we're assuming there's no friction here, all right? So when the net force is 0, the acceleration is 0. That's the first point in your data table. Now, for the next point in your data table, I'm going to put this weight on the end of the string. And I happen to know that this has a weight of 0.49 newtons. So the next point on your data table, the net force will be 0.49 newtons. Now to measure the acceleration, I'm going to use SparkView on this other Chromebook. And the cart will send a signal to the SparkView, and it'll tell, I can get a velocity time graph. And you all know that the slope of a velocity time graph tells you the acceleration, all right? So, let's get started. All right, so just to show you, so I just ran the experiment. This is the velocity versus time graph. So the part where it's sloping up is the part where the cart is moving down the track. So its velocity is increasing, it's accelerating, all right? So this part here, I started timing before I let the cart go, and then here, I kept timing after it stopped. But what I'm gonna do is I'm gonna get 3 points, 3 slopes off of that line, and that will give you your 3 accelerations that you're gonna use for 0.49 newtons, and then you'll average them together. All right, so the first acceleration is 0.1 0.25 meters per second squared, all right? Your second acceleration is 0.166 meters per second squared. And the third acceleration is 0.182 meters per second squared. So just to reiterate, so you're entering this data into a data table. I would make the left-hand column net force, measured in newtons. I would make the right-hand column acceleration, measured in meters per second squared. Your first data point was a net force of 0, acceleration of 0. For the second line in your data table, net force is the weight on the end of the string, 0.49 newtons. The three accelerations that I got were 0.125, 0.166, and 0.182. And we all know that acceleration is measured in meters per second, okay? So we've got our three accelerations for 0.49 newtons. Now, I'm going to change the weight on the end of the string, and that will change the net force. All right, so now what I'm going to do is I'm going to put this weight on the end. This weighs 0.98 newtons. So for my next data point, my net force is 0.98 newtons, and we're going to see how that affects the acceleration. All right, so you can probably guess, before we actually let this go, right, if there's more weight on the end of the string, this is going to accelerate at a higher rate, right? But we want to actually put some numbers to that. All right, so here we go. All right, so your three accelerations for 0.98 newtons are 0.311 meters per second, 0.303 meters per second, and 0.299 meters per second. If you missed those, you can go back and listen to them again. All right, now I'm going to change the net force to 1.47 newtons. 1.47 newtons. All right, so there's 1.47 newtons on the end of the string. Right, and as you can guess, now that there's more weight on the end of the string, this will accelerate at a higher rate. But let's do the numbers. Okay, for 1.47 newtons, the three accelerations are 0.473, 0.449, and 0.449. So those are your three accelerations for 1.47 newtons of net force. The accelerations are all in meters per second. Okay, now I'm going to switch this up so there's 1.96 newtons of net force. right, so this is really gonna start moving. Here we go. Here we go. Just happened. All right, well, we'll get through this. All right. We will get through this. All right, well, I guess I'm gonna have to pause while I'm waiting for this to fix itself.